1, 2, 3. These boots have counted all.
We are designing a box revisited. Okay? We've done this type of problem before. We did this in section 2.7. We're solving equations in one variable. Now we're just going to have to change it to a little bit of inequality here. Okay? Now, Dixie Packaging Company is contracted with another firm to design boxes with a volume of at least 600 cubic inches. Squares are still to be cut from the corners of a 20 by 25 inch piece of cardboard with the flaps folded up to make an open box. What size squares should be cut from the cardboard? Okay? Now, so when we do this, we need to make a box, right? So make a box. We are cutting out corners. I know this isn't to scale, but that's okay. That means if these are x's, this whole length is 25, which means this will be 25 minus 2x. This whole length is 20, so this will be 20 minus 2x, correct? That means to find my volume, okay, the volume will be x times 20 minus 2x times 25 minus 2x. Now it says, this is the crux here of the problem. It says it's got to be at least 600 cubic inches, right? So if it says it's got to be at least 600 cubic inches, what does that mean? That means the lowest it could be is 600. That means it's going to be greater than or equal to 600. Okay. Now this is where your calculator comes in. I need you to put the first part into y1. And the second part into y2. All right. Now, the other thing we have to think about is what our domain is going to be. What are the x values that it can be? Well, the lowest is 0, means you're going to cut 0 inches out of it. What's the highest it can be? Y10, then. Good. 10 will make this middle term 0. So that's our x window, 0 to 10. Now, for a y window, what we're going to have to do is figure some stuff out. I'll just give you this y window, so it'll be easier. We'll go 0 to 1,000. We're going to graph it. Now, what do you think we're going to be finding here? Let's find some intersections here, right? Intersection at 1.66 inches. Let me take a picture of it. There's one intersection. Let's find the other intersection. All right. So these are our two intersection points. We have 1.66 inches and 6.16 inches. So where is it greater than or equal to 600? Well, it's greater than or equal to 600 here, right? So our answer will be this will be our answer, and that is in inches. Okay? That's it. Does that make sense? This is just me asking, where is it going to be less than 600? This is greater than. Where is it going to be less than 600? What's the range? Okay, so it's going to be before, so what point is this though, Shane? What's x value? No. This is 1.66. Here is going to be 0 to 1.66. So less than will be 0 to 1.66 in union with what? Okay. Now one thing that I forgot to mention, because these are less than or greater than or equal to, they do need to be brackets. Okay? Now, let's move on to example 10. Now, a Stewart can or a packaged tomato juice in 2-liter, which is 200 cubic centimeter cylindrical cans. Find the radius and the height of the cans. If the cans have a surface area that is less than 1,000, this should be squared centimeters. Okay? We've done a problem like this, right? Okay? So our volume will equal 2 pi r h. Sorry, 2 pi r squared h. Right? How about I put the right formula? Pi r squared h. Now our surface area says less than 1,000 square centimeters, right? Well, first let's solve for h here. H will be 2,000 divided by pi r squared, correct? And then we're doing this. Our surface area will be 2 pi r squared plus 2 pi r h. That has to be less than 1,000. So plugging this in for h here, we'll have 2 pi r squared plus 2 pi r times 2,000 divided by pi r squared. And again, that still has to be less than 1,000. Doing some simplifying, we'll have 2 pi r squared plus 4,000 over r has to be less than 1,000. Okay? So what I'd like to do is graph that into y1, 2 pi r squared plus 4,000 divided by r. We'll have 1,000 here. Window, we could go 0 to 20 and 0 to 3,000. Okay. Again, we need to find these intersection points. And if you think back, these should be the same exact intersection points we found in section 2.7. 4.62 and 9.65. Okay, so here's what we're going to have. Now, if this has to be less than 1,000, that means less than 1,000 will be here. So that means my radius has to be less than 9.65 or greater than 4.62. Okay, this is where it gets a little different for you. thinking wise and mathematically. Okay? Now we need to solve this for h. Correct? So what we're going to end up having is this. We're going to square everything. So make sure you write this down. Okay? Then we're going to multiply everything by pi. Okay? Now, in order to make it look like the height, I need to get pi r squared on the bottom, correct? So what we're going to do, we're going to invert all of these. When we do that, we have to flip the sign. Flip the inequality. Basically, what we're doing, we're creating this formula using this inequality. Okay? Now, if I multiply everything by 2,000, oops, I think I wrote something incorrectly here. This should say squared. Oops. Which will eventually, once we figure this out, we're going to do 2,000 divided by pi times 4.62 squared. That'll give us 29.83. This is simply h. And then we'll change the 4.62 to a 9.65 with 6.84. So that means my radius must be between 4.62 centimeters, and my height, I'm going to actually rewrite this in just a second to make it look like something you guys are used to seeing. Okay? And these are in centimeters. So your height will be between those two. Okay? I mean, it's the same exact process. The only difference is when we invert the fractions here, we've got to flip the inequalities. Okay? That's what we're going to have. Okay? Now, are there any questions on example 10? I know it's a little bit different, but we've done part of these problems already. If you have a question, you need to ask me. Justin, you got a question? 2 pi r is circumference, yes. Pi r squared is area.
Is there a way to find the window? Should be
generally, you have to play with it. I know from our previous example, this is the same window we gave you in 2.7. I would say with the radius, I know it's going to be between 0 and say 15 or so. 0 and 20 is what we could use here. And with the volume, we know it's got to be greater than, the surface area has got to be less than 1,000. This has got to be greater than 2,000 for the volume, so that's why we use 0 to 3,000. Okay?